Here we're going to be finding the domain and the range, and then we're going to determine is the relation a function or not. Okay? So if not, we're going to prove that it's not by finding 2 points that contradict the assumption that it's a function. So let's start with a graph. And so I'm going to plot some points. So I'm going to go out 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Okay, so I'm going to go out here and I'm going to plot this point. We go left 2 and up 1, that's negative 2, comma 1. I'm going to go over 1 up 3, that's 1, comma 3. I'm going to go over 3 up 1, that's 3, comma 1. I'm going to go down 1 over 1, so that's 1, comma negative 1. And then over here, this is going to be left 1, down 3. All right. So is this a function? Yes or no? Domain, range. Domain, those are the x's. Range, those are the y's. So the domain here, what are the domains? The domains are negative 2, negative 1, 1, 1, and 3. So I'm going to set this up. I'm going to do a little curly bracket because it's a list of numbers. Negative 2, negative 1, 1, 1, and 3. Now, do we need to write 1 twice? If it's in there already, I don't need to write it again. So my domain is negative 2, negative 1, 1, and 3. Okay? So the range, what is the range? Well, the range, this is the y values. So the y values, what are those? That's 1, negative 3, negative 1, 1, and 3. So I've got 1, negative 3, 3, negative 1, 1. Okay, do I have any copies? Yeah, it looks like there's a 1 here, and there was already a 1 there, so I don't need to write that twice. So my range is 1, negative 3, 3, and negative 1. Okay? If you want to write it in order from least to greatest, that's fine by me. I don't care. Just get it all in there and don't repeat them. Okay, once you have it written once, you don't have to write it again. All right, so now we've got the domain, we've got the range. The question is the relation a function? Now, to ask yourself this question will tell you if it's a function or not by how you answer it. For each x, is there exactly one y? Okay, so each x has one y. So each x, so this negative 2, where does negative 2 go to? Negative 2 goes to 1. Good. Okay, that worked. Now what about this negative 1? Negative 1 goes to negative 3. Good. Okay. What about the 1? 1 goes to 3. But 1 also goes to negative 1. So each x has one y, but this x here has a y here and a y there. So that makes it not a function. Okay, not a function. So how do I say it's not a function? Because we have the points 1, 3 and the point 1, negative 1. Okay, so this would be an example where the x went to 3 and then it went to negative 1. So that's not a function. How else do we know it's not a function right off the bat? Vertical line test passes here. It passes here. Let me actually do this in green where it passes. It passes here, but where does it fail? The vertical line test fails right here. Why? Because it hits right here and right here. It hits more than one spot, okay, on a vertical line. Therefore, it fails. Vertical line test. Okay, it fails the vertical line test. All right, so therefore it's not a function. Failed vertical line test. Okay, let's try another one. Say we have a graph, x-axis, y-axis, and we have the line here, and this line is y equals 2/3 x plus 3. Now, what is the domain? Okay, Now, what's different about this versus the last one? The last one was just single points, okay? So it wasn't continuous, it was a discrete domain and range. But here, all these values, all these dots and everything in between those dots on this line here are all values in the domain and the range. Okay, so what's the domain here? The domain, I always like to think of it as from left to right. And I think of the range from bottom to top. Okay? So when I look at this, what x's are used from left to right? So I go as far as I can to the left and as far as I can to the right. So as far as I can to the left is negative infinity, and as far as I can go to the right is positive infinity. This arrow means it extends forever in both directions horizontally. So the domain is from negative infinity to positive infinity. I use the open parentheses because I can't get to infinity. Now the range is a little bit different story, only in the sense that it's vertical and not horizontal. So when I look at this, y values here work, everything up and down through here, but look, it's going forever down. So it goes forever down to negative infinity, but it also goes forever up to positive infinity. So the range is exactly the same. The range goes from negative infinity to positive infinity. And in fact, if your line is not horizontal or vertical, but it's like slanted like this, then this is what the domain's always going to be, okay? If it was horizontal or vertical, then it's a little bit different, and we'll do that problem in a little bit, okay? The next question is it a function? Well, does it pass the vertical line test? Every vertical line I draw, how many times does it pass through the line? Looks like it only passes through it one time. So yes, passes vertical line test. Okay, yes, passes the vertical line test. So if you don't want to write out vertical line test, you can write out VLT. I'll take that. Okay? So lines are functions unless they're vertical lines. All right, here's another graph. We've got 4 corners here. So this is 2 comma negative 2. This is negative 1 comma negative 2. And this is negative 1 comma 3. And then this is 2 comma 3. All right, and so we've got a box that we've plotted here. And the question is, what's the domain? Remember, the domain are all the x's. So what x's do I use here for this problem? Ooh, that's not my highlighter. Okay, the x's that I use go from here to here. Do I actually include these values? Yes, I do, because these are solid dots going on here, okay? So what is this value here? This goes from negative 1 to 2. Look at my x values, okay? Negative 1 to 2, right? So I include negative 1 and I go up to 2 and I close it. Everything in between. That's very different than negative 1 comma 2 in curly brackets. This means only x equal negative 1 and 2 are in that set. This tells me it's negative 1 and everything between, okay, that and 2. So it's everything in between. So make sure if you're going to do set notation that you do the proper thing and you have the brackets, okay? Not all brackets and curly braces are equal, okay? Now, the range is what? Well, the range goes bottom to top. So the lowest we go, it looks like the y value is negative 2. And the highest we go looks like the y value is 3. So the lowest we go is negative 2 all the way up to the highest of 3. Does this pass the vertical line test? Is it a function? No. Why is it not a function? Well, it fails the vertical line test. If I make a vertical line, passes through in 2 places. So I need to just pick 2 points. And I don't care what 2 points you pick. I'm going to pick this point and this one because I already have been given those points, right? So 2 comma 3 and 2 comma negative 2, right? So there's infinitely many you can pick. You just need to pick one. Okay, so if you say no, give me 2 points to show why it's not a function. Okay? Now, one last problem. Say you've got x and y axis and you have this line and it's a horizontal line of y equals negative 2. That means we pass through the y-axis at 0, negative 2. Okay. The domain, what x's do I use? I go from negative infinity to positive infinity. So negative infinity to positive infinity. So the domain, negative infinity to positive infinity. What about the range, though? The range is a little bit different here. The range, what y values do I use? Do I use y values up here? No, I don't. Looks like the only y value I use is this one y value right here. And that y value is y equal to 2. So the range is just a single point, curly bracket, y equal to negative 2. So when you have some finite amount of points, like the dots we had in the very first problem right here, we just had 5 dots, right? Then you use the curly brackets. Okay, if you've got more dots than you can plot, then you use the bracket or the parentheses. Okay, same with those there. And in this scenario right here, it's kind of a mix of the two because there's only one y value that works here. Okay, so does it pass the vertical line test to make it a function? Well, every vertical line I draw, it only passes through it one time. Okay. So I think so. So yes, it passes vertical line test. Therefore, it's a function. Okay.